Hello, welcome to Module 1 of our LPIC-2 Linux Professional Institute Certificate Level 2 preparation course. You're going to see that the LPIC-2 exam is mostly focused on networking and network services, in addition to the usage of tools that can be leveraged to help you manage and monitor those network services, such as DNS, email, specifically SMTP, LDAP, and many other network services. But in order to manage these services, configure, deploy, monitor, manage these services, you clearly have to understand how to use the Linux operating system, which in turn will require you to know some basic commands, some basic command line tools, and also understand how the Linux kernel works, which is going to be the object of study of our second module, Linux kernel, where we're going to discuss what the kernel is, what you can do with it, how you can deploy a new kernel, how you can recompile a kernel, stuff like that. But before we do that, in this module, we are going to focus on some basic command line tools, but although they are basic command line tools, they are also very powerful, especially when you need to monitor, when you need to manage your machine, your Linux machine, your Linux box. So you have to keep in mind that in order to deploy network services and network servers, you have to clearly understand what's going on with that specific server or set of servers. So you have to be able to monitor resources, physical resources, such as CPU, RAM, the swap memory, and the hard drive. So that is going to be our focus. So this module here is focused on what the Linux Professional Institute calls capacity planning. So to start with, we're going to analyze many different tools, command line tools. And we are going to start with some tools that you can use in order to monitor I/O, in order to monitor how the operating system is performing input, output of data, how it's interacting with the hard drive. So the first tool that we are going to look at is IOstat. And let me actually log in as the administrator, as the root user. Many of these tools, many of these tools can be used, can be executed from a regular user. However, just to avoid these issues where we would have to switch between a regular user and the administrator user, we're just going to use the admin user. So the first tool that you may have to that we want to look at, and you may have to install a package, is IOstat. The distribution that I am using here, and I am going to use in the following videos, is CentOS, or CentOS, if you will. However, it really doesn't matter. Any tool that you have, any distribution that you're using will have these tools. If you don't, you simply have to install the required package. So just make sure, in case you are using CentOS, for example, or even Debian-based distributions, make sure that you have Cisco installed. So here I have version 10.1.5.19. It's the same package if you're using a Debian. However, instead of using RPM, you should use the pkg-l pipe grep sysstat, which obviously wouldn't work here. Okay, so now I can run IOstat. Now, what can we get from this tool? What can we learn here? Why would we use this tool? The first output that you're going to see here is information about your architecture and distribution. So I can see that I am running a Linux kernel 3.10.0, and then we have the patch version. My machine name is CentOS. This is the current date. This is the architecture that I'm using, the architecture of this distribution, and the number of CPUs. Okay, based on that, we have some information regarding your CPU, in this case, my CPU. So the percentage of the CPU that is being used by users, the percentage of CPU that is addressed to when you are given priorities to specific processes, which is not the case, the percentage of CPU that is being used by the system, and how much CPU is actually in idle state, which means the CPU is basically almost 100% idle. It's not processing anything at all. Now, then you have some information about your hard drive, which is actually what you want to see, because we are using IOstat. We want to see status of the input-output data to and from the hard drive. The hard drive that I have is identified by VDA, and this can actually be seen. For example, if I run df-age, I can see that my root partition is mounted on /dev/VDA1. So the first partition of my /dev/VDA storage device, that's my hard drive. So here we can see some information such as how many kilobytes are per second are being read, how many kilobytes per second are being written, and the total amount of written kilobytes and read kilobytes. Now, you can use use more parameters, more options for the IOstat, the same way that you can do it for most of the other tools. That is why it's so important that before taking the LPIC-2 exam, you not only learn how to use these tools, but you take a good look at the man page of each of these tools. So what I'm saying is, I would recommend that you read. It doesn't have to be a thorough, you don't have to be thorough, but at least just browse over the manual page for each of those tools. So in this case, if we go to the manual page of the IOstat tool, we can see, okay, so the IOstat tool is used to report central processing unit statistics and input-output statistics for devices and partitions. Okay, we know that by now, but then you can see a better description of that tool, and you can actually scroll down. We can see up here that there are so many options, and if we scroll down, we can see how to use all those options. It will explain to you all the columns that you have available, all the columns that you can report, if you will. So there is a better explanation of all those, of all the information that you can see there. If I continue to scroll down, I can actually take a better look of the at the options. So let's say that I use IOstat with the -C option. Okay, so display the CPU utilization report. So it's focused on CPU, the -C option. The -D option is in case I only want to see the device utilization report. So as you saw, just using IOstat will show both information, CPU and I/O. If I only want to see CPU information, CPU utilization report, I use -C. Device utilization, but no CPU utilization, I can use simply the -D option. So obviously, we are not going to go through all the possible options here, but you just have to be aware that you do have many options. You do have man pages for each and all of the tools that we are going to see here, and I strongly recommend you that you do that. Another tool that we have, and you might need to install the IOtop package, because the IOtop package is the package that will come with the IOtop tool. Now, if you are familiar with Linux, most likely you know the top tool, which we are going to discuss in a minute. But if you know the top tool, you can associate IOtop with the top tool for I/O. So, again, if you know top, this is an output very familiar. This output is very familiar to you. At the top, first of all, the top tool is constantly updating the information that it's listing. Now, the difference is top is used to list the information about processes that are running. IOtop is used to do the same, also display information about processes, but associating processes with I/O. How much I/O is being generated by each process. So that's what it does. So I can see here that the total disk read is, okay, 0 bytes per second. The actual disk read is also 0 bytes per second. But then down here, you can see that information per process. Well, you can see that this machine is basically not doing anything. There is almost no I/O going on here. But you can get an idea of, okay, so for example, there is a process here with ID 1. The user that is running that process is the root user. This is how much read is in percentage. How much bytes per second is being generated, how much read operation is being generated from that process. Same thing, but for write operations, swap, if that's the case, and then we have that I/O represented in percentage. How much of the I/O operations is associated with this specific process, and then the command that is actually running that process. And again, you also have the man page for the IOtop. There you go. One thing that is important and actually very interesting to see is that similar to top, you can also run some options, execute some options that are supposed to be applied to a specific process from the IOtop interactive tool. So for example, in top, let's say that you want to kill, you want to terminate a process, or you just want to send a signal to a specific process. It doesn't matter which signal you want to send, whether it's stop, continue, kill, suspend, whatever that is, you can use the K. You can simply hit the K letter to kill a process. You can do the same thing using IOtop. Another tool that is very helpful is the VMstat tool. So let me just run VMstat, and it does show IO information, but not only that, you can see that it's a much more complete tool as far as resource usage. So you have information here about processes. You have information here about memory, swap, IO, system, and CPU. Now, there's too much information here. So we can see that we have, regarding memory, we have swap D, which represents swap used, the amount of swap memory associated with that process. I'm sorry, not associated with that process, but swap memory that is being used, how much free memory, free RAM we have, how much RAM is in buffer, how much RAM is in cache. We also have more information about swap, how much input, how much output, in general, input and output to the hard disk and from the hard disk. And then you have some information regarding the system and the CPU, how much CPU is being used by the system, how much CPU is being used by a user, how much CPU is idle, as we can see here. But I would recommend, again, that you read the main page instead of trying to understand each of these options. So, for example, this is a tool that I would like to very briefly take a look at the main page, because we can see here all those options, all that information being described right here. So, for example, in the processes columns, in the processes column, we may have the character R or the character B. And what do those mean? R stands for the number of runnable processes, whereas B, the number of processes blocked waiting for IO to complete. Why is this so important? Specifically, if we look at B, number of processes blocked waiting for IO to complete, and let's go back there, we can see that we have 0 processes blocked. Why is it important to understand this? Because the reason why the LPIC-2 exam requires you to know these commands is because they want to make sure that you know how to perform capacity planning. And capacity planning is associated with understanding how well or not a server is performing. If the number of processes that are in the block state waiting to be processed by the CPU, if this number is large, that means that machine is not being able to manage those processes as it's supposed to be, which means that you have to review either the hardware configuration that you have, or maybe you should split those services, you should split the tasks into more servers instead of just putting a bunch of stuff running in one single server. You may have to perform load balancing. Maybe you have a web server running there, but there are so many clients, so many simultaneous connections, that server is not being able to handle. Therefore, you should look for other options, such as load balancing. Same thing for free RAM. This is very important. If the amount of free RAM that you have here is low, then you should address this, because same thing for CPU idleness. If the CPU idleness is near 0 or below 20% for a very long period of time, for example, for more than 5-10 minutes, well, a CPU should not be working that hard for such a long period of time, unless, of course, there is something very critical running. So, for example, let's say that it's 2 a.m. in the morning, and that's exactly the time when you run backup schedules, backup scripts. Well, then probably the CPU usage is going to be high, which means that the CPU idle is going to be low. So this is why you have to understand, analyze these tools. Now, one additional information regarding VMstat. The first output of VMstat is not reliable. What I'm saying is, if I simply run VMstat, there is a high probability that this is not actually the amount of CPU idleness that I have. It could be more, it could be less. So that's why you should use VMstat more than once. But if I simply run VMstat once again, it's going to show me the same result. I'm going to see the same output. I have to invoke VMstat, but I have to tell it that it's supposed to update after a specific number of seconds, and I should determine the number of output reports that I want to see. So for example, if I do VMstat 3.1, VMstat 1.3, it is going to update every 1 second, and it's going to show me 3 reports, 1 per second for 3 seconds. We can see here that the second output and the third output are different from the first one. Same thing for the number of running processes. So that is something that you should look at. You can also simply do VMstat and a number. This first number is the number of seconds between each update, between each report, between each output. It will continuously run, it will continuously generate output updating every 1 second in this case. If you want to interrupt it, you can hit Ctrl C. So that's VMstat. Now, similar to VMstat, and we also looked at IOstat, which is they're both statistics tools, one for I/O, the other one for the virtual memory specifically, but also showing you additional information. We also have the statistics tool for the network usage, the network communication. We have the Netstat tool. And now let me do a pipe more here because I want it to stop when it generates the output. Okay. So whenever we're looking at network communication, basically, not only, but basically, we're going to see 2 different types of transport protocols. We can have TCP communication or UDP communication. UDP communication, called sockets, they are, which can be UDP, or it can also be the communication between processes. So they're going to be listed here in the active Unix domain sockets. But I also have the TCP connections, the active internet connections. Observe that when I run the Netstat tool, it's only showing here the TCP connections, and I'm specifically talking about analyzing the TCP segment. So observe that I only see TCP connections that are established, which is okay if that's what I want to see. Let's say that I want to see the connections, the services running in my machine, in my server, and whom they are serving, who the clients are, how many clients I have. So again, active internet connections. However, I may want to see ports that are open, which means services that are running, but maybe I don't have any current client. There is no current connection. There is no current established connection. To do that, I have some options with Netstat, such as -A, which stands for all. It really doesn't matter whether it's established or not. I also like to use N because whenever there is a service or IP, if I don't use the -N option, it's going to show the name of that service or protocol or the name of that IP address. I don't want to do name resolution. I want to see numbers because I don't want to waste any time. I don't want to lose time by resolving names. And I also want to see the processes associated with those connections. So all connections do not perform name resolution, just use numbers, and I want to see the processes associated with those connections. And I am also going to combine that with the more command because I want to freeze each page, and then I can hit the spacebar to go to the next page. So observe here that I have many local ports open. I just don't have any foreign address. I just don't have any clients connected to those ports. There you go. There you go. And I hit the space bar to go to the next page. All those ports are open. I just don't have clients connected to them. This is actually a very good tool, specifically if you want to verify whether a service that you deployed is actually running or not. And I can just keep going. And here are the established connections that I have. So a bunch of ports that are open without any client. Let's say that you want to quit. You don't want to scroll down all the way to the end. You can simply hit the Q key and it will quit. Now, Netstat has many other options. Let's just take a look at the most common options here. If I want to see the routing table, I can use Netstat -R. Now observe Netstat, network statistics. You have options to show you statistics about network and network configuration, about the network and the network configuration. Well, a routing table is a network configuration, therefore I have the -R option that would show me the routes that I have. If I want to see interface statistics, I can use the -I option. So for example, if I take a look at my ETH0 interface, the MTU is 1500 as expected because it's Ethernet. The transmission, the number of transmitted packets, the number of dropped packets, the number, received packets, dropped packets when receiving, transmitted packets, and transmitted packets that were dropped. Obviously, it's zeroed. So you can get some statistics about your network interfaces, your NICs. If you want to, again, take a look at the Netstat main page. You're going to see that you have a bunch of options. And down below, you're going to see a description of those options. For example, the -R option that we just saw, the -I option that we saw. If you want to specify, hey, I just want to see information about a specific interface, you can use the -I and specify that interface. If it was a kernel 2.6 or below, you could use the -M option to see if your kernel is masquerading the data, while in kernel 3.0 and above, that is not a feature anymore. So many options here, such as the -N as we saw. So you should take a look at these at the main page as well. Now, similarly to Netstat, we also have the SS tool. Oops, let me do a pipe more as well.